judgment, and structural reconstruction in complex vitreoretinal surgery. This video demonstrates a petaloid self-cooling internal limiting membrane carrying technique for macular hole repair. In this selected case, early anatomical closure observed after air tamponade. The goal of this technique is not merely to close the hole, but to reconstruct the facial acupuncture with minimal trauma. After staining, the internal limiting membrane around the macular hole is clearly visualized. The first step is to design controlled petaloid arm flaps around the hole. When initiating the flap, the key is not force, but choosing the correct vector of traction. The instrument should remain on the arm plane as much as possible, avoiding repeated manipulation of the foveal floor or RPE surface. Instead of aggressively tucking the arm flap into the hole, I gradually create multiple petaloid arm flaps around the macular hole. Each flap is kept soft, mobile, and able to self-cool naturally. The purpose of the petaloid design is to allow the air flaps to gather towards the central like petals. This creates a gentle autologous tissue cover rather than forcing tissue into the base of the hole. At this stage, the natural retracting and cooling behavior of the arm become visible. The surgeon should work with this tendency, controlling the direction of the flap without over manipulation of the base of the macular hole. The key maneuvers are stability, gentleness, and predictability. Each traction should serve flap formation and coverage rather than aiming for a wide or rapid peel. Once multiple arm flaps have been created around the hole, they tend to gather towards the center. This preserves the flexibility of the tissue and reduces the direct disturbance to the RPE bed. In selected cases, I use air tamponade rather than relying immediately on long-acting gas or silicone oil. The principle here is no aggressive tucking, no repeated contact with the foveal floor, and allowing the air flaps to complete the coverage naturally. Post-operative OCT demonstrated anatomical closure of the macular hole with improved macular architecture compared with the preoperative status. These results support the potential of this technique for early and gentle macular reconstruction in selected cases. The three key concepts are patelloid elm design, self-cooling behavior, and minimizing direct manipulation of the RPE and the foveal flow.